Hello everybody, this is Amel Peralta with another interview preparation video for you. And this time I'm going to show you the four-sum problem, which is similar to the previous problems we solved before, the three-sum and the two-sum problem. So it says, given an array nums of n integers and an integer target, are there elements a, b, c, and d in nums such that a plus b plus c plus d equals target? Find all unique quadruplets in the array which give the sum of target. So in this problem, they give you an array nums and the target, and they want you to find all the quadruplets that add up to the target. So for instance, they give you this array and the target is 0, and all the quadruplets have to be unique. So for instance, the solution here is these three quadruplets. For instance, -1 plus 0, -1 plus 0, -1 plus 1 is 0. So that's equal to the target. And -2 plus -1 is -3 plus 1 is -2 plus 2 is 0. So that's also equal to the target. And also -2 plus 0, -2 plus 0, -2 plus 2 is 0. That's equal to the target. So note, the solution set must not contain duplicate quadruplets. Alright, so this is the problem. So the naive way to solve the problem is to actually have four nested loops. So you're gonna have a time complexity of big O of n to the 4 power, which is not the best you can do. That's the brute force solution. So how can we optimize this? We can actually improve the time complexity from big O n to the 4 to big O n cubed by using the same technique that we were using before with three-sum. So what we're gonna do is that we're gonna have 4 pointers. First we're gonna sort the array in ascending order, and then by sorting the array we're gonna have 4 pointers, and we're gonna be able to reduce the four-sum problem to the three-sum problem. So as you can see, this is a general technique for this type of problem. So in general, you can solve the k-sum problem in time complexity of big O n to the k minus 1. So for instance, if you have the three-sum problem, using this technique you can solve it in big O n squared. If you have the four-sum problem, using this technique you can solve it in time big O n cubed, and so on. So without further ado, I'm going to start coding this question. And as a note, the solution set must not contain duplicate quadruplets. So in order to take care of this, we're going to have to check for duplicates every iteration. But because the array is sorted, all the elements that are the same are going to be next to each other. They're going to be adjacent to each other. So that's why that's going to allow us to check for duplicates every iteration in a simple manner. So without further ado, I'm gonna start coding this question. First, the result list of integer result gets the value of new array list of integer. So if the reference is null, or the number of elements in the array is less than 4, there's no possible solution to the four-sum problem, so we can return an empty result list. Return result. I'm gonna sort the array, as I said before. Arrays that sort nums, and then I want to save the size of the array in a variable. Alright, so now I'm gonna have the 4 pointers I, j, left and right. So I'm gonna start with I. For integer I gets a value of 0, I is less than the size of the array, plus I. Okay. For integer j gets a value of I plus 1, j is less than the size of the array, plus j. And then I'm gonna have integer left pointer gets a value of j plus 1, integer right pointer gets a value of size minus 1. So as you can see, I have, in the first iteration, I'm going to have I here, j is going to be pointing here, left is going to be pointing here, and right is going to be pointing at the last element. Okay, so now I can use the same principle of the two-sum problem. While the left is less than the right, I'm going to calculate the sum. Integer sum gets a value of num sub I plus num sub left plus plus num sub j plus num sub left plus num sub right. So I'm adding up those four numbers, the one at position I, j, left and right. If the sum equals the target I'm looking for, then I have one quadruplet, one solution. So list of integer L gets a value of new array list of integer L that add num sub I, L that add num sub j, L that add num sub left, L that add num sub right. Okay, and finally results that add this temporary list, this list L. Okay, so now we need to take care of duplicates. So we want to make sure that we take care of duplicates for the left pointer and the right pointer. So I'm gonna save the old value of left in a variable. Integer left value gets a value of num sub left. Then while the left is less than the size of the array and num sub left is the same as the old left value, I keep incrementing left. That way I'm gonna take care of duplicates, because if I have duplicates, they're gonna be adjacent to each other, so I can check if this element that I'm looking at now is the same as the old left, and as long as it is true, I keep incrementing the left pointer. Okay, and the same idea I'm gonna use for the right. Integer right value gets a value of num sub right, while right is greater than left and num sub right equals or is the same than the all right value, then I keep decrementing right. Okay, so I handle duplicates here. Now that was the case if the sum is equal to the target, to the number I'm looking for. But if the sum if the sum is less than the target, then I want to make it bigger. Remember, to make it bigger, I increment the left pointer, because all the numbers to the right of left are bigger since I sorted the array in ascending order. Also, else, if the sum is bigger than the number I'm looking for, then I need to make the sum smaller. I can do that by decrementing right, because all the numbers to the left of right are smaller. Alright, so now I need to handle, so I handle duplicates for the left pointer and for the right pointer. Now I need to handle duplicates for the j pointer. Okay, so for the j pointer, I'm gonna do this. While j plus 1 is less than the size of the array, making sure that I'm within bounds, and num sub j plus 1, the next element, is the same as this element I'm looking at, keep incrementing j. So that's gonna handle, this is gonna handle duplicates for the j pointer. And now we need to handle duplicates for the first pointer, the I pointer, using the same idea. While I plus 1 is less than the size of the array, and num sub I plus 1 is the same as num sub I, keep incrementing I. So this condition is going to check that both are true, that both have to be true, that it is within bounds, and then if it is true that it is within bounds, then it's gonna check if the next element is the same as this element, then keep incrementing the I pointer. And finally, we return the result. So let's check if this is working properly. Alright, I get the same output as the expected output, so this is probably working perfectly. So let's submit the solution. Alright, success. So 45 milliseconds faster than 63% of Java submissions for 4 sum. So this is a fast solution, it's better than a naive solution. So as I told you before, the brute force or naive solution takes time, big O, n to the 4. But using this technique, sorting the array in ascending order and having this pointer left and right and these 4 pointers in this manner, instead of having 4 nested loops, we only have 3, and the time complexity is only big O n to the 3rd power, or big O n cubed. So my name is Amel Peralta. Please like this video. Please don't forget to subscribe if you want more videos like this one, and happy coding, and see you next time. Thank you.